so starting off, we just want to name what a proportion is. Now, this is going to be really similar to a different definition that we have in class, or already have in our notebooks. However, a proportion is going to be a part in relation to a whole compared to another. Now, a part in relation to a whole compared to another. We've seen the first part of this definition before. A part in relation to a whole thing, that's a fraction, right? We named that is how we think of fractions back on the first, or in the first week of school. And so when we have essentially a fraction compared to another, what I want you to picture in your head is exactly what we've been seeing for cross multiplication. Okay, I'm going to have one fraction set up equal to that second fraction. Don't necessarily know what the values are. We're going to get into that. But I got to have one fraction set up equal to another fraction. Once you have this definition, flip your notes so that I can see. Sorry, thank you. Over there. All right. So, example 1. Who can read example 1 nice and loud for me, please? Gabby, nice and loud. Ooh, louder. Thank you very much. So, I know he can do 8 math problems in 5 minutes. The question is, assuming that this is the same constant rate, how many can he completely solve in 27 minutes? Okay. When we're setting up proportions, the first thing I'm going to do is start with the ratio or fraction that I know based on the problem. I know that he can solve 8 problems per or in 5 minutes. I know that he can do 8 problems per 5 minutes. Okay, well, what I need to find is how many problems. Well, hang on a second. Raise your hand. If I don't know how many problems, what should I use to represent that? If I don't know how many problems, what should I use to represent that? Should I? X. Well, then I need to find, okay, X problems per 27 minutes. Now, because of this wonderful phrase, at this rate, I know that when I look at these two fractions, they need to be equal. And so I know that 8 problems over 5 minutes has to be equal to however many problems, so X problems over 27 minutes. Okay, well, let's take a look. I'm going to rewrite this just so that the units aren't quite with it, because the annotations get a little messy with it. And so I'm going to have, okay, so really 8 over 5 is equal to X over 27. Well, hang on a second, because now this looks like, well, frankly, exactly what we just did on the do now. I'm going to use cross multiplication to solve this. I know I'm going to have, okay, X times 5 and 8 times 27. So I'm going to have 5x is equal to, I'm going to start by writing 8 times 27 so we know where this number comes from. But help me out. Somebody who has a calculator, what is 8 times 27? Gabby, very fast. Louder. Louder. 216. And so 5x is really equal to 216. Okay, well, if I want to solve this, what do I do on both sides? Okay. One more time, louder.
Divided by 5.
Divided by 5. Okay, well, when I divide by 5, I'm going to learn that x is equal to... Now, before I even get there, this question came up last block. Why are we not going to want to leave this as a fraction? Eden. It's going to turn into a decimal? Yes. Why, in this case, are we going to prefer the decimal to the fraction? Kyrell. Say it one more time. One more time. It's, well, if we think about it, not necessarily a smaller number. I think I get where you're going in terms of it might be a more simple number. Gabby? Yes, louder, because that's it. Yeah, if I look at you and go, oh, well, Robert can solve 216 over 5 problems in 27 minutes, you're going to go, that's useless. That tells me nothing. Because it doesn't. And so 216 divided by 5, somebody with a calculator, what is it? Eden. 43.2. 43.2 what? Keyshawn? Problems. Right? We named up above that we have X problems. I want to make sure that those units stay. Units are going to be really important today. All right. I know that X is 43.2 problems. Let's go back up. Full question. What is the number of problems Robert can solve completely in 27 minutes? Now, this word completely is super important because it means that we're going to have to do what with our answer? Okay, well, let's take one step back. If we think about complete problems, what type of a number should I give as an answer? Gio. Louder. A whole number. And so if I jump back down, I actually don't want this decimal when I'm thinking about my solution sentence. And so if he can solve 43.2 problems, what is the number of complete problems he can solve? Gio. 43, right? We're just going to round it down. And so, because this is a word problem, we need to have this solution sentence. Robert can completely solve 43 problems in 27 minutes. There's our full and final answer. Now, I'll zoom in so it's a little bit easier to see. When we work with proportions, I'm going to argue that about 85% of the work is setting it up. I saw in the do now, we can cross multiply and get those one-step equations pretty easily. 85% of the work is truly setting this up. And so I want you to go back up and actually look at our setup. What do you notice about this setup in this line? What do we notice? Jose. Yeah, the first thing you saw me do was name, okay, what do I actually know? Because then I'm going to go to, okay, well then, what do I need to find? I need to name, what do I know? And then that helps me build, okay, then what do I need to find? And so based on what I know and what I needed to find, what do you notice about those two fractions? What is the same on those two fractions? Uh-oh. I want to know what is the same on those two fractions. Turn and talk. 20 seconds. Go. I'm not. It's a send out. All right, and let's bring it back in 3, and in 2, and make sure that we're all the way back in 1, please. Charles, should you get head up, please? All right, thank you. Shamir, just make sure you got eyes. Paolo, make sure you got eyes. We're there. Keyshawn, thank you. Zion, thank you. We're there. Aria, Gio, there. All right. Raise your hand. What's the same about these two fractions right now? Gio. Say it again louder. The units. I want to be more specific. What do you notice is the same about these units? So yes, I have the same units. I want to really focus this in. What do you notice about what part of the fraction they are in? Gabby? What is special or specific about what part of the fraction the units are in? So we know we have to solve for it. Helps us set us up. I'm gonna help us out here. I have problems over minutes on the right. Does that change? Does that change? No. Problems over minutes. When we set up proportions, your units need to line up. You need the same unit left to right over the same unit left to right. And so I need that to be our key takeaway, because we're about to practice this, and this is going to be the #1 error if we are not careful. When setting up proportions, our units must match left to right. When setting up proportions, our units must match left to right. And so specifically, numerator and numerator, same units. Denominator and denominator, same units. So again, when setting up proportions, our units must match from left to right. If they don't, we cannot solve. If they don't, we cannot solve. All right. With that, we're going to pause on notes. Set it aside. We'll come back to example 2. I want you to practice this. And so jump into your packet and take a look at problem set